Hello, my name is Mateusz Czapliński, and I'm here to tell you about this slightly crazy project that I created, which is to build an Android APKs in pure nim. So, first, as a kind of introduction, I want to show you a small demo of the result. So here we have some kind of a programmer art like Flappy Bird clone, and as you hopefully can see, it is reacting to touch events. And this was done purely in nim. So let's get started. My main motivation for this was that I want to create some apps for myself, and I would really like to avoid Android Studio for that. So I tried various technologies, and in particular the React Native one has this interesting idea of a bridge that kind of made me thinking. So basically, because the Android APIs are only available to Dalvik virtual machine code. So they wrote a bridge, a small tiny wrapper in Java, converted it to DEX format, and any logic is basically written by users in JavaScript. And there is some kind of communication layer between the bridge and the logic. Some APIs are exposed to JavaScript that can now use them. So my idea here was, what if I could somehow make this bridge part be automatically generated? So I don't have to ideally write it in Java, just have it like magically done by computers. So that's what I wanted to do. So I went to see how a DEX file looks. So a DEX file is basically quite a simple format. There is a lot of references around. Most of that is simple. What is interesting here is that there is this table of strings. So most of those references in some way or another point finally into this table of strings, of which everything is built. Plus there is like I'd say only a non-trivial part of the format of the file, which is the code. But if you look a bit more into it, it shows up to be not so difficult either. So the registers here are basically local variables for a function, because you define your code in functions or methods. Every method has some registers which are like local variables. And other than that, it's basically like writing Java just in binary. So I was expecting this to be much harder, like x86 Intel assembly, but it shows up to be much more like Java. So if you get back to the previous idea, we want this basically only for this bridge or glue part. So we want it to be as thin as possible. So basically all that is possible are just shims for methods. So if we add a native qualifier to a method in this DEX or Java file, this means for Dalvik that the definition, the implementation of the method is actually in native code. So that's all that needs to be there, except constructors. Unfortunately, they can't be native. So I synthesized some Dalvik bytecode here to build constructors. And we need to tell Dalvik through this like static initial call of load library that where our native nim code exists. So once we do have this thin DEX wrapper, glue bridge, we still need to pack it in an APK to deliver it to the Android device. So now an APK file is actually a glorified jar, which is a glorified zip. Apart from the classes DEX, an APK file requires a manifest file, which is an XML, but it's not. So you write it usually as an XML, so you put some meta information there. It's like the name of the project and like the main activity class. And then you translate it to a binary format. They still give it the extension XML, just to confuse us. And then there are files which are originate from jar format, and those are basically hash of all the contents of the jar or APK, plus some signature for signed APKs. So that's it for a minimal APK, but we are not completely minimal because in our case the DEX part is just a glue. So we still need to add the actual code that will be compiled with nim, and then with Android NDK compiler, though I hopefully would like to try and do it with Zig instead. So one important thing here is we need to remember the architecture. So every architecture we want this APK to support must be included here and built cross-compiled properly. So the content of this logic, the part of the logic is structured as you would structure your regular Java application writing for Android. So you must have an activity, then you must have like a view inside, which is a window where you will draw, and you might, if you are writing a game, you might want to do the logic on a separate thread and just post the events of changed graphics to the view here. So like a snippet of the code from this actual application is here. There are some tricky parts. So you must create a data field here, which is like a magic name that is recognized by JNim to do the connection between the Java world and the nim world. So then there is the JExport macro, which wraps a lot of complexity in a simple way. So this is how you declare your code of your class and that it extends or implements some Java classes or interfaces. You can add some constructors. They can take arguments, but they are automatically, the implementations currently automatically call super with the same arguments. You can add some of your own methods with your logic. You have some features thanks to JNim, like this or super. You call constructors with new. And there is this part that is required for DEX, because mainly nim script, I hoped to do this compile time, everything of the DEX generation, but unfortunately nim script seems to be kind of not supporting a full nim language and all features, and not all of standard library is available in nim script, so I didn't manage to do this that way, and I'm creating a separate nim file that is just compiled in a second step. So if you would like to run this, the steps go like shown here. You clone this project, then you build the manifest, so translating the XML to the binary format. For this, the Nimble file will automatically download the helper tool I created for translating XML to the binary format and run it. Then you will call the dex task, which does the generation of the actual dex file with the intermediate step that is required because static compilation won't work here. Then you compile the SO library, so the native code. For this you need Android NDK for now, though I hope to maybe use Zig for that. That's what I'd like to do to make cross-compilation easier and to get rid of Android Studio completely. Though Android NDK is a separate download, so it does not require the whole Android Studio, definitely. And the final part is a Nimble APK, which will pack those files and generate and hash the signature for hashes and signature for the file. You need to provide like the private key and certificate for that. Here again, I created a separate tool. I did it in Go because I couldn't find libraries in Nim that would help me do that, and I found them for Go. Sometime later, some guys helped me in part to find some crypto primitives for this, but for Nim, I still missed ASN1 library, but there is an article from Let's Encrypt that I read recently that finally helped me understand ASN1. So I'm kind of started and would like to maybe try and migrate this tool to Nim as well. And the final command is just to install this APK that's already built quickly into your device. You can also do it just by uploading the APK somewhere and downloading, or through an SD card, whatever you prefer. I would like to show you how to build and install the app on an actual Android device. So the first step is to clone. From the Flappy branch to the Flappy directory. Okay. Please notice there is no APK directory here. I can even show it like this. Okay. So, first thing we do is manifest. Let's see what there is the manifest file. Next step. Okay. Once again, let's see the APK directory. So now we got the classes dex as well. Here we see Android NDK is running. So we got the manifest, we got the classes glue, and we got the native library. So what's left is to package them into an APK. So here we can see the input files and the files that were added to the zip. Okay, and for the final step, here's the phone. The app is here, so I want first to uninstall it. Yes. Okay, it disappeared. I'm plugging it into cable. So it's there, and now I push it. So the app is again here. So something is showing up. Not sure why the colors are so weird now, but that's how it is. But you can see something moving at least. A quick glance into the Dali code. So like the main function here is render, and it is kind of shows you a part where I built the header of the text file. So there is some magic string. Here I used macros to help me structure this in a way that I find readable. So here I allocate a slot for a value that will be inserted later. So this is like a hash of the whole DEX, which can be calculated only at the end where all the data is filled. But we allocate space for it here with some operator overload and stuff like that. So like super cool features of nim for me. In still like statically typed. Okay, so about the state of the project, it works. So I find this app advanced enough that I believe that stuff can now be built with this project, useful stuff. There are some features that are still not there. So I built this like an MVP way, so minimum thing that can possibly work. So things that I didn't need yet are not there yet. If I start writing apps using Dali, I think I expect I will slowly add any missing features, but maybe there will be no need for them as well. There is, other than that, there is like this challenging area of the battle between garbage collectors. So Nim has its garbage collector and Java has one, and they don't know about each other. So we talked with Yuri, and we don't know of a way to make sure you are safe against cycles here and against leaks. So for now, I think the only way I know of is to be careful to not create cycles, unfortunately. If someone knows of a way this could be resolved, that would be awesome, if you could share. Other than that, it's kind of brittle. So there is, when I'm writing this, unfortunately I have to do tons of logcat dumping and browsing, and that is kind of challenging, but also that's kind of how you live on the bleeding edge. It's not the first time I'm at this place, so that's kind of what comes with this place. So the final point here is that for code reusability, we cannot really use jars in this situation. So if code reusability is to become something, there we will need to find a way to invent something how to do that. But it's still early for that, and I believe it certainly can be done this way or another. So some things I would like to do as the next steps if time and fancy permits me. So for example, I would like to do a tutorial based maybe on this presentation, how to build the Flappy project. I would maybe like to simplify it by merging the few tools into one some way, though it's not completely obvious how to do that. I would like to have this done during compile time, but there are kind of limitations in NimScript that I don't know how. I don't think it's possible at this time. I would like to use XCC instead of Android NDK. There is this thing with, like, when you want to include images in an APK, they should usually come as resource files. This needs to go similar way like this XML translation part to binary format. So this is again something that would need to be added for images to be included in projects in a proper way. Signing, so I would like to rewrite the Go code to Nim. Okay, and the final point about contributions. So I would be really happy to accept if you just want to accept any contributions to the project. The thing is, that's kind of not the only project I have. And experience showed me that its maintenance is kind of boring. So I might not have energy to kind of follow up on contributions. So if you want to go the safe way, I recommend forking. I'm very happy to get contributions, just I cannot promise anything that I will. I'm happy to discuss, especially that's kind of easier, but merging stuff, sorry, let's see, if you want to share with me, I'm super happy. How is this will go, we can see. So that thing here mostly is about my time. So I'm actually starting a new job next week. It's full-time, and this means I won't have much time for hobby projects. I would love to find a way to work more on my open source projects, but I know that's not easy. So if you would like to help me in this somehow, like to help me have food and have money for food, for clothes and similar stuff, I am happy to work on open source projects. But for now, that's where my work must fund it, so my time for open source projects is limited. And then the final point is about the license, because I heard from some people some concerns. Oh, that's GPL. That is kind of I don't like GPL. That's like the viral license. So please, one thing to note here is that GCC is also GPL. So this is a compiler, in basically speaking, or an assembler. So the product you make with Dali, it's not encumbered by any license, just the compiler. And also, still, you can use it commercially if you want, just share the code. That's how I wanted this code to be. Because I believe this gives it some chance of sustainability, that it may live longer, that people may want to use it for independent projects and might want to contribute to it, not being afraid of it being grabbed by someone for proprietary reasons and taken over. You can take it over as a commercial company, but please share the code. That's the only thing I ask for, so that if you go down, which happens, the code can live on. That's basically the general idea here. And again, products that you create with Dali, the idea is they can be licensed any way whatsoever that you want. Okay, so finishing with Dali itself, a few words about Nim in this context. We are on a Nim conference, so without Nim I wouldn't create this project. That was a huge enabler for me, so thanks a lot to Andreas and all the contributors for creating Nim. I really liked it. I really liked it especially for prototyping. I like the readability. There are many things here I like. There are also things I think could be improved. So for me personally, like the main thing that's tricky and difficult for me is that every time I want to get to the documentation of the standard library, I have trouble finding anything there. If I know about something that's there, if I already know, then it's a bit easier. But if I don't know if something's there or is not there, I have basically to browse through the whole page or the index like on the left side and just scroll through it by names and search if there is a name that might sound like something that is for me. And there could be, I believe this could be organized better. There could be some grouping. There could be less, like by topic or by type. That's what I would really hope there. Also, there is a lot of repetition, and I would love if there were maybe either no repetition in the index or at least keep the repetition but show full signatures so that I know so I can browse and see what I'm scrolling through. Still, I also fully aware that docs are now in a much better place than they were like half a year or maybe a year ago. And that's, I think, basically thanks to one guy who just came and improved them. So again, huge thanks for everybody who contributed to the docs. Still, I think that's the place where we can talk about what can be improved. So other smaller areas in my opinion. So testing of macros. I have like two macro packages I'd like to share, but I find it tricky to test them. I would love if it was easier to test macros. Exceptions. Okay, so there is something I was thinking about. I like exceptions for prototyping, but I also like the model of Go and Rust for kind of later stage projects, maybe for robustness, for making sure all errors are handled. So I got this idea, maybe there could be like a pragma that could be used, and finally something between a pragma and compiler flag that you start when you want to make your code like gradual typing. So in a similar way, gradual error robustness. So you could maybe mark regions of your code with a pragma that would switch them to kind of Go-like Go-like way of handling errors and tracking all of them, making sure they are all handled. That's kind of idea. So just something I thought about. Code reordering. I love to use it. I believe it helps me structure the code easier, in a more readable way. What's unfortunate is that nim-suggest seems to not work for it, at least for me. I'm not sure if I'm the only one or this is actually a limitation of nim-suggest. So I would love if nim-suggest could work with code reordering. And the final point here is about nim-script. So initially, when learning nim, I thought maybe I could use nim-script to replace Lua for me. But now I see nim-script is actually kind of limited and not fully supported. So I don't feel at this point it's stable. I mean, not stable is maybe not a good word, but complete enough with regards to nim that I could really use it for things I use Lua for now. I would love if that was possible. I think it's not. So the final thing I wanted to do is to say once again a huge thank you not only to Andreas, but to many people who contributed to nim itself, as well to some other projects. So in particular, Yuri and his JNim, it's tons of work he put there, and it's really an awesome project. I heartily recommend it. It saved me tons of work, and I collaborated a lot with Yuri. He's a great guy. He helped me merge Dex support to JNim. And also even some challenges I had and some bugs I had, he helped me resolve them. So then there are some other people, and especially I would like to thank the people who probably are not on this conference, but maybe someday will listen to this presentation. So the guys who created the minimal projects with minimal Dex file and with description and a minimal APK file that I could base on. And that's basically it from me for now. Thank you very much and see you, and I hope I will be able to answer your questions regarding the project. See ya!